So good afternoon, everyone. Okay, so good afternoon, everyone. I am Keshav. This is week 10. So I am currently a research scholar at IIT Kanpur. So I will be taking this week 10 of problem solving session of the course NPTEL-ME111, which is applied numerical method. Okay. So I hope you all are able to see my screen. So till now, what we have discussed in this course, first we have discussed linear algebra part. In linear algebra part, what we have discussed? We have discussed two type of problem. First was what? First one was AX equal to B type of problem, means system of linear equations. We have seen how we can solve system of linear equations. There we have seen both the direct methods and iterative methods. Direct method, we have seen Gauss elimination method, which was famous one, and another one was in iterative method, Gauss-seidel iteration and Jacobi iteration. Okay, then we have seen how we can find out the eigenvalue and eigenvector of a square matrix. Means what? Means this is typically an eigenvalue problem. There we have seen the power method. By using the power method, we can find out the absolute maximum eigenvalue and its corresponding eigenvector. Similarly, we can use inverse power method to find out the absolute minimum eigenvalue and its corresponding eigenvector. Okay. Then by using the shifting method in the inverse power method, we can find other eigenvalue and corresponding eigenvector. Then we have came to the calculus part. Here in numerical methods, we do not have a continuous data, rather than we have a data only on some discrete points. So first we have seen how we can do the differentiation using this discrete data. This differentiation can be of initial value problem, or it can be a boundary value problem. Means what? Solution of differential equations. We have also seen how we can do the numerical differentiation. Then we have seen numerical integration. Before going to numerical integration, we have seen the interpolation. Interpolation means what? Interpolation means what? We have discrete points. We first find out an interpolating polynomial that passes through the given discrete point. Then we have integrated the interpolating polynomial to find out the numerical integration. Then we have seen what? Application of finite difference method. There we have seen time marching problem and steady state and unsteady state 1D heat conduction problem. Right? So now what we'll do, we'll go towards the week 10. In week 10, regression has been discussed. Regression is nothing but learning from the data. Okay. Please respond whether you are able to hear me. Okay. So let us consider a simple problem. So we have a voltage V, voltage difference V, that has been applied to a copper rod. Okay. This is a copper rod. So we wish to find what will be the amount of current that will flow in the copper wire. Okay. So as from theory, as from our earlier knowledge, we know that this current I will be related to V by R from Ohm's law. So from the theory, we know this relation. So this is called as mechanistics model. Okay. When we know the mechanism that is governing the underlying physics. Okay. When we know this is known as mechanistic model. Okay. So let us assume that we know this relation for this problem. So in this equation, what is unknown? R is unknown. Okay. And what is known? Suppose we have done the experiment for different voltage VI and we have calculated the, we have not calculated, we have measured the current II. Okay. So what is known? Known is VI, the voltage difference that we have applied, and the measured current II. Okay. Then what we want to do? We want to find out some I star when we apply voltage V star. Okay. So this we want to measure, not measure, we want to calculate, predict. So what will be the relation? There will be some random errors or random noise that will be related to our experiments. Okay. This random error will have zero mean. And how it will be originated? It will be originated from large number of unknown sources that are beyond our control. Okay. If it is a controllable parameter, then we can change the parameter accordingly to control the error. But this is kind of random error that is beyond our control. Okay. So due to that, there will be some epsilon I term in every I. Okay. So if you see this equation, there are n equations. For every I will start from 1 to 2 goes to n. So for every I, we have one equation. So means what? We have n equations. How many unknowns we have? We have one unknown R and n unknowns of epsilon I. So we have n plus one unknown. Okay. So if we have an equation and n plus one unknown, in that case, we'll not able to get the unique solution. Okay. So let us go for a simpler case where we assume there is no noise or we neglect the noise. In that case, our I will be equal to V by R. So for every I, we will have a equation. Okay. So here, how many number of equations? N number of equation. How many unknowns we have? Only R is the unknown. So number of equations are more compared to the number of unknowns. So most likely, what will be the case? We will have no solution. Okay. So this kind of problem can be arise when we have a mechanistic model. Okay. So regression is the technique. Regression is the technique that is used to solve this kind of problems. Okay. So here what we do, we consider the effect of noise, but we do not try to evaluate the noise directly. Okay. So we try to find out a regression fit where we consider the effect of noise, but we do not calculate the noise directly. So now let us see what is mechanistic model and what is empirical model. So mechanistic model comes from the theory. When we know the underlying complex mechanism of the physical problem, then we can derive this mechanistic model. Okay. And sometimes what happens, we do not know much about the underlying mechanism. In that case, by using the data that we have, we can apply a empirical model that is data driven. Okay. this method, this empirical method or empirical model is generally used when we do not have a good mechanistic model. Okay. So to understand that, let us consider a problem where we have a solid propellant. So there is some data has been given to us that with respect to the age, how its shear strength is changing. Okay. So suppose in week 1, it is having some strength. In week 2, it is having some strength. Week 3, at the end of week 4, at different week, at the end of different week, we have some values of the shear strength. Okay. So by seeing this data, we can directly say that this data is linearly dependent on the age in weeks. Okay. So what we do, a linear from this data, we can say that a linear empirical model seems likely to predict the value. Okay. So once we have assumed that the linear empirical model seems right, what we'll do, we will use the regression to build this model. Okay. And once we build the model by using the regression, we will predict the strength at given age. Okay. Clear? So now let us consider. So what is the fundamental of regression? Suppose if we have I equal to V by R. So what regression will try to do? The regression will try to estimate R in such a way that the effect of noise on R is minimized. Okay. So we want to minimize the effect of noise on R. In that way, we will estimate the resistance. Okay. Now, what is the goal of regression? If we have a mechanistic model, if we do not have a mechanistic model, if mechanistic model is not available, we will develop an empirical model that will be data driven. So if the mechanistic model is not available, the empirical model will be developed using regression. Okay. And if the mechanistic model is available, we will find the parameters such as R using the regression method. Okay. So if the mechanistic model is not available, we will use the data to develop an empirical model by using the regression. And if the model is available, we'll find out the parameters such that we can reduce the effect of noise. Okay. Then once we have developed the model for any given V star, we can find I star by using the model. Okay. So this regression is nothing but this regression is a part of machine learning, which is nothing but a learning from the data. So this comes under a family of supervised machine learning. This comes under supervised machine learning. So let us start with simplest case, which is a simple linear regression model. Okay. So here what we have some data that has been given to us, xi and yi. Means what? We have some, for some x1 value, we have some y1. For some x2 value, we have y2. Some x3 value, we have some y3 dot dot. For some xn value, we have yn. So this is the given data. Given data is xi, yi, where I goes from 1 to n. Okay. Then what we try to do, we from the given data, this is the given data. We want to predict the value. Suppose my x is x star, then what will be the value of y star corresponding to this x star? We have only one thing known, this data. This data is given to us. Okay. So we will not find the y star directly, but we will try to estimate the y star hat. Okay. What do we mean by y star hat? Hat means what? It is kind of prediction. So it is prediction means what? It will not be an exact value. Okay. As I have told, this regression is a family of supervised machine learning. So data, this data XIYY, this data XIYI that we have is known as training data. Okay. So the input, the XI is known as a regressor or the feature, and the YI is known as the response or label. Okay. These are the terms related to machine learning. So we know the prediction will be much more easier if we have a mechanistic model. Suppose we have some y, which is a function of only x. So if we have a model like this, then what we'll do? We do not need this point xi, yi. We directly put here y star will be equal to y of x star. So we'll put the x star value here and calculate the y star. Okay. But if this is not the case, then we will go for the regression. Okay. So we are assuming that our data, whichever is given to us, the training data, which seems linear. This we assume here. If the data seems linear, then we can assume some y that will be equal to theta naught plus theta 1 multiplied by x plus epsilon. This epsilon is random error that will have zero mean. Okay. But unfortunately, we cannot find theta naught and theta 1, as we have seen in the case of the voltage difference applied on a copper rod. There was n equation and n plus 1 unknowns. Similarly, here also number of equation is less than the number of unknowns. So we cannot find the theta naught and theta 1. So we will use what? We will use the simple linear regression fit to approximate the model. Okay. So what we'll do? We will assume some y that will be equal to w naught plus w1x w1x plus e. This e is what? Residual. So y can be written as y hat plus residual. So this y hat is called as least square estimation of y. Okay. So this y hat from here can be written as y hat will be equal to w naught plus w1 multiplied by x. So this w naught is called as bias, and this w1 is called as weight. Okay. So these are also called as regression coefficient. So w naught and w1 are what? Least square estimation of theta naught and theta 1. Okay. So if we can find out this w naught and w1, we can find out this y hat. So this y hat will be an estimation of what? Y. Okay. So to find how we can find out this w naught and w1, we can find out this w naught and w1 by minimizing the cost function. How the cost function is defined? The cost function e, which is a function of w naught and w1, is equal to 1 upon n summation of I goes from 1 to n li, where li is what? Li is loss function. So li will be equal to ei square. Okay. And what is ei? Ei will be equal to yi minus yi hat. Okay. So from here, if we put the ei here, so capital E of means what? The loss function, sorry, the cost function, that will be equal to w naught, that will be equal to 1 upon n the first term y1 minus w0 minus w1x whole square plus y2 minus w0 minus w1x2 whole square plus dot dot. Similarly, for the nth term yn minus w0 minus y w1 xn whole square. Okay, this will be the my cost function. Now what I will do, we will try to minimize the cost function. Okay, so E is function of w0 and w1. So it will be a minimum or maximum when the partial derivative of del E upon del w0 and del E upon del w1, that will be 0. Okay, so for the minimum, these two conditions must be satisfied. So from these two conditions, if I put, I will get two equations. From these two equations, I can find out the w0 and w1. Okay, but by satisfying this equation may not be sufficient to say that this is a minimum. So for that, we need to verify this condition, these two conditions, to say that whatever the w0 and w1 we have found, that will lead to the minimum E value. Okay, clear? So let us now find this and these two values. So del E upon del w0, what will be the value of del E upon del w0? If you see this term, just this term, here we see w0. Okay, so if we calculate the differentiation, this 2 will come here, this 2 will come here, and the differentiation of this term will be -1. So -2 will be -2, it will come -2, that -2 comes outside. So -2 y1 minus w0 minus w1x. Similarly, here also -2 will come, that we taken outside. So this is what we will get once we will do the differentiation with respect to w0. Okay, so this can be written in terms of summation. So -2 by n, summation of I goes from 1 to n, yi minus this term, this is present n times, so it will be equal to n multiplied by w0, and w1 will be common from each. So minus w1, summation of I equal to 1 to n xi. So that will be equal to what? That can be written as 2 multiplied by w0 plus w1 x bar minus y bar. Okay, this will be equal to what? 0. So this is the equation we will get once we will do the del E upon del w0 equal to 0. Similarly, if we do the del E upon del w1, -2 will come outside. But if we do the differentiation of this term, one additional term x2 will come. So if we do that, so similar to that one, in that case, 1x1 will come. In this case, 1x2 will come. In this case, 1xn will come. So similar to that case, we can write in the terms of summation. So the summation will be equal to -2 upon n. I goes from 1 to n xi multiplied by yi minus w0 minus w1 xi. Okay. Now what we'll do? We will directly multiply xi in the bracket and take summation of individual terms. If you do that, what you will find? You will find this 2 multiplied by w0 x bar plus w1 x square bar minus x multiplied by y bar. So what we have get? Once we have done the w upon this w0 equal to 0, that lead to this term, no? This term. From here, if we take this y bar, into the RHS, what we'll get? Y bar will be equal to W naught plus W1 X bar. Similarly, if we do what we have got when we have did what? When we have did del E upon del W1 equal to 0. That lead to XY bar equal to W naught X bar plus W1 X square bar. Okay, these two we have got. So these two it has been written here. This is what we have got, and this is what we have got. Now this is one linear equation. This is a second linear equation. So this is my correlation coefficient. So the equation for finding the correlation coefficient is known as the normal equation. So this equation and this equation is called as the normal equation. So my regression will be called as a linear regression if my normal equations are linear. Okay. Now from these two equations, I can find out the W0 and W1 value. How we can find out? If we directly multiply X bar in the first equation and then subtract it. So what we'll get? We will get this. No? W1 will be equal to X multiplied by Y bar minus X bar Y bar divided by X square bar minus X bar square. Here it will be X bar square. So it will be what? It will be X bar square. Okay. So once we have found out the W1, we can directly find out the W0 by using the first equation. Okay. So that will be Y bar minus W1 X bar. Okay. Once we have found out this, our ultimate goal was what? To find out this Y hat star. That will be equal to W0 plus W1 X star. Okay. So this is how we can find out the regression coefficients here. So you can remember this formula by using that W1 cross multiplication xy xy divided by the x1. So x square. Okay, you put a minus sign here. You take together both, here also together both, here individual, here individual. Okay, like that. Now we will see what the alternate form of this W regression coefficients. So if you see here, W1 equal to X Y bar minus X bar Y bar divided by X square bar and X bar square. So we can write in the terms of summation. Now from here and here, if you see, this 1 upon n and summation can be taken outside. No? So, and you multiply both denominator and numerator by n and take summation outside. That will lead to summation of I equal to 1 to n. Here from here xi minus x bar multiplied by yi. In the denominator, what we will get? Summation of xi square. And here what we'll get? N multiplied by x bar square. Okay. Now, what we'll do? We can write this term like this. How we can write? Let us see. So let me add one page here. So what we want to find? Xi minus x bar square I goes from 1 to n. Okay. This is what we want to find. So this will be equal to summation xi square minus x bar square plus 2x bar minus 2 xi x bar. Okay, I goes from 1 to n. Now if you see that summation you take in every term, this will be summation xi square plus this x bar is constant, that will come outside, summation of 1 minus 2 x bar will come outside, summation of xi. Okay, so this will be equal to what? Summation of xi square plus this will be n times x bar square minus 2 x bar multiplied by this will be what? If I write x bar is equal to what? 1 upon n summation of xi. So from here I can write n multiplied by x bar. So if you this term will get subtracted. So xi square minus n x bar square can be written as summation of xi minus x bar whole square. Okay. So that is why this is written like that. So this term is called as SXX and this term is called as SXY. Okay. Clear? Now let us see one more term here. Summation of I 1 to n xi minus x bar multiplied by y bar. If we see this y bar is constant, it will come outside. So this will be equal to summation of xi minus x bar. So this y bar will remain as same. This will be but summation of xi minus summation of x bar. So this will be equal to what? N multiplied by x bar, and this will be also equal to n multiplied by x bar. So this and this will get cancelled. That will lead to 0. So s of xy we have here, we have what? F of xy like that. So xi minus x bar yi. So I have subtracted 0 from here. So this is nothing but 0. So now we can take these two terms together. That will lead to sxy, that will be equal to xi minus x bar multiplied by yi minus y bar. Okay. So this is what written here. So from here, W1 will be equal to what? Sxy divided by Sxx. And xy is this and xx is Sxx is what? Summation of I goes from 1 to n x minus xi minus x bar square. Now we can verify whether this is actually minimum or not. So we can find out these three terms. And once we do this to verify the expression, if you do that, you will get this term. This term is what? Xi minus x bar whole square. This is a positive term, and summation of positive term will lead to a positive term. Means what? The whole expression is greater than 0, which means what? It is indeed a minimum. Okay. Clear? So what we have did in simple linear regression, when it will be called as simple linear regression, when we have one regressor, one response, then it will be called as simple. And if the relation between them is linear, then it will be called as simple linear regression. In that case, we suppose we have this training data. We take input 1 and x. We give the weightage 1 to W0 and give the weightage x to W1, and we do the regression and find y hat. Okay, so this is the whole procedure what we are doing in simple linear regression. Okay. So these are the input. This is the output. This is the weightage. Suppose now we have done the regression. So what will be the quality of regression? How we can find out whether the regression that we have done is good? How much good it is, well enough to predict the value or not? That can be determined by the regression quality. So here in simple linear regression, W can be written as Sxy divided by Sxx. Okay. Sxy and Sxs is defined like that. Okay. So if we write residual will be what? Ei will be equal to yi minus y hat. Okay. This can be written like that. I have put the y hat value W naught minus W1 xi. Okay. So now what we can do here, we can put the W naught value. W naught will be what? Average minus y bar minus W naught x bar. So we can put this value here, W naught. Then we will find this expression yi minus y bar minus W1 xi minus x bar. If we take the summation, this term will be this term lead to 0, and this term will also lead to 0. Okay. So the summation ei will be equal to 0 always. So means what? The residual is not giving us a correct information about the quality of the regression. We need to go for other method. So let us see this yi minus y bar. So this yi minus y bar can be written as y hat minus y bar and yi minus y hat. Okay. Now if we take the square of this term, plus 2 cross multiplication. This is what we'll get here. Okay. Now let us calculate this cross term. So this cross term will be equal to what? We know W naught is equal to y bar minus x bar W1. So I can write y hat that is equal to what? W naught plus W1 x. It can also be written as the value of W naught we'll put here. So this will be equal to what? Y bar plus x minus x bar W1. So from here we can write y hat minus y bar will be equal to x minus xi minus x bar W1. Similarly, we can write y minus y hat that will be equal to, you put the y hat value from here, then you put the this W naught value in this term, then you will get this expression. Okay. So this is what the expression we have got. So expression will be what? First term will be what? Xi minus x bar W1. Second term will be what? Yi minus y1 minus x minus xi minus x bar multiplied by W1. Now you take the multiplication of this term inside here. This will lead to this term. Okay. So if we take the summation, this will be equal to what? This is equal to nothing but summation of this will be equal to xi minus x bar yi minus y bar. This will be equal to sxy. So I have written xxy. Similarly here it will be sxx. That will be equal to sxy divided by W1. From there W1 will cancel. So xxy minus sxy will be equal to 0. So this term will be equal to what? 0. Okay. So this cross term equal to 0. So similarly, we can write directly from here that yi minus y bar whole square summation will be equal to yi hat minus y bar whole square plus summation of yi minus yi hat whole square. So this is called as sum of square of residual. This is called as sum of square of regression. This is called as sum of square of total. Okay. This S of t is called as sum of square of total. Capital R is called as sum of square of regression, and this is called as sum of square of residual. Okay, so we can define the term coefficient of determination that will determine the goodness of the fit, which is represented as R square. That R square will be equal to sum of square of regression divided by sum of square of total. So from this expression, we can write this will be equal to 1 minus sum of square of residual divided by sum of square of total. Okay. So this term will be always less than the denominator. So my R square will be always between 0 to 1. Okay. If this term is between 0 to 1, I can take the under root of this term. No, don't do that. First, we'll put this value. Okay. So this value that will lead to W1 SXX. So SXX can be written as SXY divided by W1. So it will be equal to W1 SXY. So now you put the values here. So R square will be equal to SXY W1 divided by SYY. How SYY denominator is what? Summation of Y minus YI minus Y bar whole square, right? So this is nothing but SYY. So now you put the W1 value here. That will lead to XXY whole square divided by SXX SYY. So if we take the under root, the R will be equal to what? SXY under root of divided by under root of SXX SYY. That will lie between what? -1 to 1. This is called as coefficient of correlation. Okay. So from all this analysis, what we can say, if my R square goes to 1, which means what? The regression line runs close to all the data and the variation of Y is well captured by the regression. If R goes to 0, means what? It is fails to capture the variation in Y. Okay. If R is greater than 0, means what? As we increase the Y, as we increase the X, it will lead to increase in Y, which means what? It has a positive correlation. If R is less than 0, which is called as negative correlation, means what? As we increase the X, Y will decrease. Okay, like that. If R equal to 0, so there is no correlation between the data. Means what? This X and Y are not linearly dependent. Okay. Means what? What the assumption that we had that X and Y are linearly dependent, so that we had put this linear regression. We had done the linear regression fit, which is not correct. The data is not linearly dependent. Clear? Here. Hello. Please respond whether it is clear or not, and also respond whether I am audible clearly. Okay. So till now, what we have XI independent and YI dependent. Okay. So like that, we have training data, but we can have multiple independent regressors. No, means what? We can have multiple X1, X2, X3 kind of regressors, and corresponding Y labels or response. Okay, in that case, what we can do? We can go for multiple linear regression. In multiple linear regression, what we do? We will do the linear regression for more than one regressor. Okay. So here we can have training data in terms of like that. We have K regressors and one response. Okay. So let us start with easiest one, where we have two regressor. Okay, which means what? We have the data tau xi1 and xi2 corresponding to, we have response yi, where I goes from 1 to n. Okay, so let us assume a linear model that will be equal to y hat will be equal to what? W0 plus W1 x plus w2 x2. Now what will be the cost function? Here in this case, cost function E will be the function of W0, W1, W2, both all of three. Now this will be equal to what? 1 upon n. The summation will go from 1 to n for every yi minus y hat. That y hat is what? W0. We put minus y hat. It will be equal to minus W0 minus W1 x1 of I minus W2 x2 of I. Okay. Now similar to the earlier case, we need to find out these three terms and we need to enforce it to 0 to have a minimum value. If we do that, del E upon del W0, that will be equal to, it has square. So once we do the differentiation, it will come here. This 2 will come here. This 2 will come here. Now, if we do the differentiation of this part, this is constant, this is constant, this is constant. So it will be equal to minus 1. So that's why we have taken minus 2 outside this summation. Okay. Similarly, if you do the differentiation del E upon del W1, earlier we have what? This we have square. So this 2 will come here. 2. Now this is constant for W1. This is constant. This is constant. The differentiation of this will be equal to, with respect to W1, will be equal to minus x I of 1. That's why we have written minus x I of 1 here, and we have taken minus 2 outside. Similarly, this will be equal to the differentiation del E upon del W2. Now, if you see, we have three equations. To do some manipulations, this will lead to this equation. We have three equations and three unknowns. So this is nothing but a system of linear equation that can be solved for W1, W2, and W0. So by using this three equation, three unknown, we can find out W0, W1, and W2. Once we found out, we can estimate W y hat star, which is the ultimate goal of regression. Okay. Now we can consider x2 as x square, which will lead to y equal to W0 plus W1x plus W2x square, which is non-linear relation. But here also we can apply, what? Here also we can apply linear regression. As long as our normal equation is linear, we can go for this linear regression method. Okay. Similar for the K regressor, we can see like that. The same equation will come, but with the K regressors. Okay, so K equation, here what we'll have? We will have K equation, K unknowns that can be solved using system of linear equations. Okay, solution of system of linear equations. So this is kind of complicated one. So now we'll go for vector notation. That will be a simpler case to implement in computer program. Okay. So what we are doing in linear regression, suppose we are considering a simple case. Now we are going for vector notation. So what we are giving two input, 1 and x. These are the input. We have defined the weight for 1 is W0 and weight for x is W1. And we are doing the model to get the output y hat. Okay, this is what we are doing. So we are now considering the simple here regression, and we will represent in the form of vectors. Okay. So in vector format, this x can be written as x0 and x1 in column vector, or it can be represented as a transpose of row vector. Okay. So this x will be equal to 1 x1 transpose. Similarly, regression coefficient can be represented as W, that will be equal to the column vector W0 and W1, or it can be written as a row vector W0 W1 transpose. So what will be my Y? Y will be equal to Y hat will be equal to W0 plus W1 X. Okay. So this can be represented like that. X0 1 X W0 W1 inner product. If you take, it will be equal to what? This will be multiplied by this will be multiplied by this, and summation. So W0 plus W1 X. So this can be represented like this. Here. Now means what? Any Y I hat can be represented like Xi transpose multiplied by inner product W. Okay. So this Xi is what? 1 Xi of 1. Okay. So now we have what? We have n data. For each data, we can find out n Xi. So we can define a matrix capital X that will be equal to 1. That will be equal to this X will be equal to what? This X will be equal to the transpose of this 1 I1 transpose. It will be represented like that. So it can be written as 1x11, 1x21, 1x31, 1x1, 1xn of 1. So in this case, we can represent y will be equal to y hat will be equal to x multiplied by w. W will be equal to what? W will be equal to W0, W0. Okay. So now the least square here, E of W can be represented like that. 1 upon n summation yi minus yi hat square. This can be represented like that in the vector format. That will equal 1 upon n y minus y hat transpose multiplied by y minus y hat. Okay. From here, we can replace this y hat equal to x y. So this will be my what? This will be EW. Now you take the derivative. Del E upon del W0 and del E upon del W1. If you take the derivative, this will be my derivative. Now if you see here, this is my yi, this is my yi hat. So this will be equal to minus 2 by n yi minus yi hat. Similarly, this will lead to minus 2 by n summation x I1 yi minus yi hat. So this gradient can be represented like that in the vector format. So this x transpose will be equal to what? 1 in second row, x11 1 in second row, x12 like that. If you do that multiplication, it will lead to the same term, this term and this term. Okay. Means what? Our gradient is equal to minus 2 upon n x transpose y minus x w. Okay. So for minimization, this gradient must go to 0. Means what? This term should be equal to 0. So this term cannot be equal to 0. Now you multiply this x transpose in this term and take one term other side. So that will lead to x transpose x w will be equal to x transpose y for the minimization. This is nothing but a system of linear equation. Okay. So from here you can find out the value of w. Once we have found out w, from here we can find out y hat. Okay. So what we have got here, we have got that for minimization of grad E, this will lead to x transpose x w will be equal to x transpose y. Okay. This will be my system of linear equation in W. System of linear equation in W. Okay. From here, we will find out the value of W. Okay. Then what we'll do? We'll find y hat that will be equal to x W. Okay. By using these two equations, we can solve the whole problem. So if we have the k regression, we have k regressors, then also the equation will come like that only. Only thing is here, we have that was equal to 1 x11, 1 x21, 1 x31. Now we will have k regressors like that, x11, x12, x1k. Here also we have one more regressor for 2, kth regressor for 2. So this will be my x value. And in this case, my W will be, earlier my W was what? W was W0, W1. Now here we have W0, W1, dot, K unknowns. Okay. So the same expression that we have derived for the simple linear regression case can be used. Only X and W will be different in case of multiple regression, multiple linear regression. Now we'll see non-linear regression. How we can do the linearization in non-linear regression. Here what we'll do, we will transform the non-linear to a linear regression. By seeing, we can use the example like that. This is a non-linear relation. But if we take the log ln in both sides, it will be equal to ln of y hat, ln of w0 plus w1 ln of x. It as y hat is y dash hat is this ln of w0 to w0 dash and w1 to w1 dash and ln of x to x dash. Then it converted into a linear type of relation, which means what we can apply linear regression. Okay, so here what we have w hat, which is related to w0 x w1. We have taken the ln both sides, so ln w hat ln w0 plus w1 ln of x. So this is a linear relation. So this we have assumed some value. This we have some w0 dash. This y is to x star dash. Okay, like that we have converted into a linear, but it has some limitation. What limitation it has? By assuming this kind of relation, we are assuming that our noise is a multiplicative type. Okay, once it is a multiplicative type, when we take the ln, it will become into the additive type. So that can be solved using the linear regression. But if the error is itself is a additive type, then maybe this linearization may not be acceptable. Okay, clear? So this is what has been discussed in week 10. Okay, clear? Now we will solve some problem. This is the problem we have. So we need to use the least square regression fit to find y equal to a0 plus a1x through data. This is the data that has been given to us. Y at x equal to 1 is 1, y at x equal to 2 is 6, y at x equal to 3 is 29. So we need to find out this value, a0 and a1. Okay. So we need to find this value a0 and a1. So here what we have, so first problem I will solve, then you will solve the next problem. Okay. So here we have some x. Maybe I should select some different color of the pen. So we have x, we have some y. Okay. So x is what? 1, 2, 3. Y is what? For 1, it is 1. I hope so. It is 1, 6, and 1, 6, and 29. So it is 1, 6, and 29. Okay. Suppose I want to find what? A0 and A1. Na? So A1 will be equal to what? XY total bar minus XY individual bar divided by X square of bar minus X bar square. Once I will find out the A1, A naught will be equal to what? Y bar minus A1 X bar. Okay. So here what we need? I need X Y bar, X bar Y bar, X square bar, and X bar. Okay, this is what I need. So for that, I will calculate X square X Y. Okay. If I calculate the X square, 1 square is will be what? 1. 2 square will be 4. This will be 9. Now multiplication, this will be equal to 1. This will be equal to 12. This will be equal to what? 7, 8. Okay. Now I need to find out what? X bar. So from here, X bar will be equal to what? 1 plus 2, 3. 3 plus 3, 6. 6 divided by 3. It will be equal to 2. Now Y bar will be equal to what? Summation of this plus this 7. 7 plus 29, that will be 36. 36 divided by 3, that will be equal to 12. Okay. Now X bar, Y bar, that will be equal to what? This plus this summation of these two terms, 13. 13 plus 87, that will be equal to 100 by 3. Similarly, X square bar will be equal to what? X square bar will be equal to what? Summation of this will be equal to 5. 5 plus 9, 14. 14 divided by 3. So this is what I have got. Now we will directly put the values here. So what will be my value? X bar Y bar. X Y bar is equal to 100 by 3 minus X bar is what? 2. Y bar is what? 12 divided by X square bar, 14 by 3 minus this is what? 2. 2 square. So it will be equal to 100 minus this will be equal to what? 12 6 72 divided by 12 minus 3 multiplied by 4, 12. So 28 divided by 2, that will be equal to, so from here, A1 will be equal to what? 14. Okay, so this is what we have got, find out the A1 value. Now I need to find out the A naught. A naught Y, summation of Y was what? 12 minus 14 multiplied by, this is what? This is 2. So it will be equal to minus 16. Okay, clear? Now you solve this problem. Now you solve this problem and tell me the answer. Okay. So here in this case, what we have here in this case, same kind of problem is we are fitting Y equal to A naught plus A1 X, but here the data is different. At X equal to 1, it is 1. At X equal to 2, it is 2. Sorry, it is 4. And at X equal to 3, it is 27. Okay. We need to find A0 and A1. Okay. So A0, A1 will be what? XY bar minus X bar Y bar divided by X square bar minus X bar whole square. And A2 will be what? A0 will be what? Y bar minus A1 X bar. So what we need? The XY bar, X bar, Y bar. These terms we need, na? So you make a table like that, X, Y, X square, X, Y. Okay, this is 1, 2, 3, 1, 4, 27. So this will X square be 1, 4, 9. This will be equal to what? 1. This will be equal to what? 8. This will be equal to what? 81. Now you find out the summation X bar y bar, x bar will be equal to 2, y bar will be equal to what? 5, 32, 16, nahi, 32 divided by 3. Similarly, x square bar will become like that, 14 by 3. X y bar will be equal to what? 16 and 7. Let me calculate that. So xy bar will be equal to what? 90 by 3. So it will be equal to 30. 30. So my A1 will be equal to what? From here, my A1 will be equal to xy bar 30 minus x bar y bar. X bar is what? 2. Y bar is what? 32 by 3 divided by x square bar is what? 14 by 3 minus 4. So A1 will be equal to what? 30 minus, you know, 90 minus 64 divided by 2. So A1 will be equal to what? This difference will be what? 26 divided by 2. So it will be 13. Once it is 13, so A0 will be what? My y bar minus A1 x bar. Okay. So y bar is what? 32 by 3 minus 13 divided by 2. So it will be equal to what? It will be equal to what now? 26, 13, 43. That will be equal to what? We'll do the calculation. Now 32 minus 3 multiplied by 2 multiplied by 13 divided by 3. That will be equal to, so it will lead to 46 minus 46 minus 46. So it will be 15.33. Okay. So A0 is what? 15.33 and A1 is my 30. So you see here, only one thing we can do the calculation mistake. So while doing this kind of problem, you make sure you do the calculation slowly. Okay. Here. Now we will move towards the next problem. So next problem is like that. Here. So this is my problem. We need to consider this data x and y are given. We wish to fit y, which is closely equal to w naught x divided by w1 plus x. Using the above data and appropriate transformation to linearize the problem, we need to find out the w naught and w1. Okay. For this data, using this relation, we need to use the transformation to go for linear regression and find out the value of w naught and w1. Okay. So this problem you need to also do, and I will also do. So before doing that, let us see what we can do here. So here we have y hat equal to W naught X divided by W1 plus X. Okay. So from here, what we can do, if we take the reciprocal both side, it will equal to W1 plus X divided by W naught X, which will be equal to W1 divided by W naught 1 upon X plus 1 upon W naught. Okay. So if I assume this to some Y1, this to some A1, this to some A0. Okay. So my above problem has been converted into Y1 equal to A0 plus A1 X1. Okay. This is my problem. Here what we have where we have A1 equal to W1 upon W0 and A2 equal to, sorry, A0 equal to 1 upon W naught. Okay. From here, if we wish to find W naught, that W naught will be equal to 1 upon A naught. And once we have found out this, I can find out A1 will be equal to, sorry, W1 will be equal to what? W1 will be equal to what? W1 will be equal to what? W naught A1. Okay. From this, we will find out first W1 and this A1 and A naught, and using then this relation and this relation, we will find out W naught and W1. Okay. So here what we have now, we have some X, we have some Y. So we need to find out this X1. This X1 will be 1 upon X, and this Y1, which will be equal to 1 upon Y. Then we need to find out X square. Then we need to find out XY, sorry, X1, Y1. We need to fill the table. Then we need to find out what? After filling the table, we need to find out X bar. X1 bar equal to what? Y1 bar will be equal to something. X1 square bar will be something. And X1, Y1 bar will be equal to something. Once we will find out these values, we'll put this value, find out A1, that will be equal to X1, Y1 bar minus X1 bar, Y1 bar divided by X1 square bar is X1 bar whole square. Okay. Then we'll find A0 will be equal to Y1 bar minus A1 X1 bar. Okay. Once we'll find out this, we'll find out W naught will be equal to 1 upon A1 and W1 will be equal to, sorry, A naught, A1 W naught. Okay. Like that we'll find out. Now we need to fill this table. What is the data that we have? Let me write the data here. So we have the data 1.3, 1.8, 3, 4.5, 6, 8, 9. Okay, this is the data we have. For Y, what we have 0.07, 0.13, 0.22, 0.275, 0.335, 0.35, 0.36. Okay, this is the data we have. Now we'll find out. Now we'll find out what? We'll find out X1. Okay, and then Y1. Then X1, Y1. Then X1, square. Okay. So you tell me the value of x1. You do the square. Sorry, you do the inverse and tell me the value. So I am also doing here. So 1.3 inverse. That will be equal to 0.769. Okay. Then if I do the inverse of what? 1.8 inverse, that will be equal to 0.555. Okay. Now 3 inverse, 0.333. Now what? 4.5 inverse. That will be equal to what? 0.222. Are you able to hear me? Now 6 inverse will be what? 1.0.167. Okay. Now 8 inverse 0.125. Now 9 inverse will be what? 0.111. Okay. Now y1 we need to find out. So 0.07 inverse is 0.07 value. I am correct. Let me check. 0.07. 0.07. So 0.07 will be what? Its inverse will be 14.285. Okay. Now 0.13 inverse 7.692. 0.22 inverse will be what? 4.545. Now 0.275 inverse 3.636. Okay. Now 0.335. This inverse will be what? 2.985. Now 0.35 inverse will be what? 2.857. Now 0.636 inverse 2.777. Okay, this is what we have got. Now we need to find x1 y1 multiplication. You please do by yourself also. Otherwise, there is no need to doing this problem here. Okay, please try to do by yourself. Now we need to do the multiplication. So 0.769 multiplied by 14.285. 14.285, that will lead to 10.985. Then what? Then 0.555 multiplied by 7.692. That will be equal to 4.269. Now 0.333 multiplied by 4.545. That will be equal to 1.513. Now 0.167 multiplied by 2.985. That will oh, so one value 2.33 के बाद नहीं ये नहीं So this will correspond to 0.498. By 3.636. 636. 636. 0.807. So 0.125 multiplied by 2.857. 2.357. 0.111 multiplied by 2.777. 0.308. Now we need to do the square. 0.769 square. 0.591. 0.555 square. 0.308. Now 0.333 square. 0.110. 222 square. That will be equal to 0.049. 0.167 square. 0.0278. 0.125 square. 0.0156. Now 111 square. 0.0123. Good. Now we need to find this A1 value. Okay. You please calculate the A1 value. Sorry, before that we need to calculate the summation of this. So what will be the value of x1 bar? X1 bar value. Let me do by myself. X1 bar value will be what? 0.769 plus 0.555 plus 0.333 plus 0.222 plus 0.6167 plus 0.125 plus 0.111 divided by how many terms are there? 7 terms, I think. 1, 2, 3, 4, 5, 6, 7. This will be equal to 0.326. Correct? Now I need to calculate the y1 bar. 14.285 plus 7.692 plus 4.545 plus 3.636 plus 2.985 plus 2.857 plus 2.777 divided by 7 will be equal to 5.539. 5.539. Okay. Now x1 square we need to find out. X1 square, the last one, 0.591 plus 0.308 plus 0.110 plus 0.049 plus 0.0278 plus 0.0156 plus 0.02, sorry, 0.123 divided by 7. That will be equal to what? 0.1591. Now what we need to do? We need to calculate the xy bar. That will be equal to 10.985 plus 4.269 plus 1.513 plus 0.807 plus 0.498 plus 0.357 plus 0.3088. That will be equal to this divided by 7. So 2 point something, we will be getting 2.6, 2 point. Please verify these values are correct or not. Good. Then we need to find out this A1. Okay, so A1, we need to find out this A1 now by using this formula. Please tell the value of A1 and A0. So if I calculate here, to exclude 0.676 minus 2.676 minus 0.326 multiplied by 5.539 divided by x square 0.1591 minus 0.326 So this even 16.4. Yeah. What will be the value of A0 then? Y bar, Y1 bar minus A1 X1 bar. So Y bar is 5.539 minus 16.475 multiplied by X1 bar 0.326. 168 or something we are getting. If I take the inverse of this, $5.947. This is what we are getting for W0, and W1 will be equal to W1 will be equal to A1 W0. No? From here, if you see A1 W0, yeah. So W0 only A1 is what? 16 point something, na? 16.45 or so. 16.475. $97 point something I'm getting here. Am I correct? Good. So now we move to the next problem. The next problem is like that. We have some data set for x and its corresponding y value. We wish to fit this y equal to w naught plus w1x plus w2x square. Using the above data, we want to find out the w0, w1, and w2. So what we'll do? We'll use the multiple linear regression fit, right? This is what we'll do. So what we'll do? We will assume x1 will be equal to x and x2 will be equal to x square. That will lead to these three equations. Na? First equation will be w1 like that only, w1 plus x1 bar plus, sorry, w naught plus x1 bar w1 plus x2 bar w2, that will be equal to y bar. Second equation will be what? This equation will multiply by the x1 bar. So the x1 bar w naught plus x1 square bar w1 plus x1 x2 bar w2 will be equal to x1 multiplied by y bar. Similarly, del E upon del W3, W2, that will lead to this equation. X2 bar W naught plus X1, X2 bar W1 plus X2 squared bar W2, X2 Y bar. Okay. So here we have X1 Y value has been given. What is the value? 0, 0, 0. At 0, it is 1.8. At 2, it is 1.3. At 3, it is 2.5. At 4, it is 6.3. So we need to find W2. W2 will be equal to x square. So this will be equal to 1, this will be equal to 4, this will be equal to 9, this will be equal to 16. Okay. Now what are the terms here unknown? X1 bar, X2 bar, X1 square bar, cross multiplication X1, X2 bar, X1y, X2y, and X2 square. So we need to find X1 square, X2 square, X1y, X2y, and X1, X2. Okay. So let us evaluate these values. We'll take only 5 minutes. We'll just quickly try to find out the values. Okay. You tell me these values as soon as possible. So if we do here x1 square, that will be equal to 1, 4, 9, 16. This will be equal to 1, 16, 51, and this will be equal to what? 256, I guess. Now I need to find the multiplication of this term and this term. So this will be equal to 0, 1.8, 1.8, 2.6, 7.5, 2. Now I need to the multiplication of this term and this term. 0, 1.8, 5.2. This will be equal to what? 22.5, I guess. Okay, this will be 25. Now this and this multiplies 0. This multiplication will be what? 1, 8, 27, 64. Okay. This is the values that we have got. Now we'll put these values here. We'll put these values here. We'll solve this simultaneous equation to get the desired values. Okay, W1, W2, and W3. If we do that, I am writing the directly what will the value that will we get. So we will get W0, that will be equal to 0.5343. W1 we will get minus 0.2986, and W2 will get W2 will be equal to 0.4071. Okay, this is the value we will get. You please note down these values and try to verify, not now, at your home. Okay, after this meeting. Please note down the value. Okay, so let us move ahead. Now what we'll do, one practice problem. In that, what we'll do, we will consider the same data point and we will try to fit the same regression fit. But here now we will write a computer program for that. Okay. In computer program, we will find what is the value of W0, W1, and W2. Then after finding out these values, we will plot the data set and the regression line. Okay. Clear? This is what we want to do now. So here the vector notation will be easier to implement in the computer. So we know by doing this gradient of E, which is a function of W equal to 0, we will get this equation X transpose X W, that will be equal to X transpose multiplied by Y. Okay, this is the system of linear equation for W we will get. And once we will find out the W, we will put Y hat will be equal to X multiplied by W. Okay. So here the X will be equal to what? W will be equal to from W to WK, and X will be what? There will be K regressor and there will be N rows of K regressors in X. Okay. So here in our case, what will be the value? W will be W0, W1, W2. X will be what? 1, X11, and X11 square. Similarly, for second data, we'll have 1, X21, X21 square. 1, X31, X31 square. 1, X41, X41 square. 1, X51, X51 square. This is the values we have. Okay. Then once we have that this X, we'll use this condition to find out the W. This is the W that we will get. And once we will find out the W, we'll use this equation to find out Y. Y hat will be equal to X W. Okay. Okay. So let me stop share from here. I will start share from my computer. I hope you are able to see my screen and you are able to hear me also. Please respond whether you are able to hear me first thing and you are able to see my screen. Okay, so now I am going to start here. So first thing what we'll do, we will define the data. No, we'll define the data. So before doing anything, first we will define the data. So first I will clear everything that is available. Clear all. Now what I will do, I will load or find. I will load or find the test data. Okay. So there will be some value of x and there will be some value of y. So what is the value of x here? This text when you are not able to hear it, because earlier in the last class when I was trying to write the program, at that time I was not audible. If you are if you are able to hear me, please respond that I know. Okay, thank you. So my x is what? 0, 10, 1, 2, 3, 4. Okay. 1, 2, 3, 4, 5 values I have. Corresponding y what I have? 0, 1.8, 1.3, 2.5, 6.3. Okay. So I have now loaded the data. Now what I will do? I will do the multiple linear regression. I will do. For that, I need to define the. I need to define what? X. I need to define the x is the vector that at x is the metric that I need to define. So I want to define capital X that will be equal to. In the first row, it will have only one. Huh? It will be equal to ones, and size will be what? Length of. So this is my first column. Now in the second column, what will we have? In second column, what we will have? In second column, we will have x, and in third column, we will have x multiplied by x. Okay. So this is the values. Now we see whether I am going correctly or not. Okay, so this x in an array to multiply, I need to put a dot before that. So here is my x. I have did length of x, so it has converted length of x cross length of x. Here, comma 1. See, this is my x. Now I have defined the x. So What I need to do now? I need to find the W. No? Finding W. How we will find out the W? By solving system of linear equation. Okay. System of linear equation. Which system of linear equation? System of linear equation will be what? X transpose multiplied by X multiplied by W will be equal to X transpose multiplied by Y. This equation will solve to get the value of W. Okay. So you remember we have made the Gauss function, Gauss elimination function like that in week 4 or so, or week 5, where we have given the input A and B. If we wish to solve A x equal to B type of problem, we have made a function Gauss elimination where we need to give the input A and B. Okay. So here A is what? Here A is in this, and B is what? B is whole term. This. So now I need to define A and B. So A will be equal to what? X transpose, no? X transpose. So X dot, this will give me the transpose here, multiplied by X. X transpose X. This will be my A. Now my B will be what? B will be what? X transpose X transpose multiplied by Y. This is my A and B. So B A is 3 cross 3 and B is my 1 cross 3. Now I need to call the Gauss elimination function that I have made, or I can directly use the inbuilt MATLAB linear solver. But I will call my so W will be what? W will be GAUS Gauss A and B. Now then what we'll do? I will display W, the display of W value. Now if I run this, see my W is coming like that. This is the same value that we have got by doing the hand-based calculation. Okay. So I have found out the W, which is nothing but calling Gauss elimination. Okay, now we need to do the plotting. So now plotting. I need to plot two things. Na? So first I will open a new figure by using figure is. Then I will plot X and Y. I want to do the scatter plotting here. I will do like that. So I am doing star. I use the in star symbol I want to plot. Then I need to hold this figure on. So I will do the hold on. Hold on. Then I will plot the next one, which is X comma Y hat. But before that, I need to find out the Y hat. Na? Y hat will be what? Y hat will be what? X multiplied by W. So X multiplied by W. Okay. After this this is my y hat. Now I will do the plotting. This is my, these dots are my training data, and this is my regression fit. Okay. Here, I have done some, what we will say, some garnishing on the plot. So if I run this plot, this kind of plot we will get. So this is my regression fit. This is my training data. This is value of x. This is value of y. Okay. Here. Okay. So we have 10 minutes. So let us solve the problem that was remaining. One problem we have remaining now. This is the problem. So you tell me here x bar value. Okay. What will the x bar value we will get here? Sorry, x1 bar. X1 bar. X1 bar will be equal to 1 plus 2 plus 3 plus 4 divided by कितना data है 5 points ना. This will be equal to 2. Okay. Now x2 bar will be equal to what? 1 plus 4 plus 9 plus 16 divided by 5. That will be equal to 6. Now what? X1 square bar, that will be equal to 6. Now we need to find x2 square bar. Okay. X2 square bar will be what? I think you will be able to solve this problem. Why I will do again. Okay, so this is what we need to discuss in week 10. Do you have any doubt? Okay. So what we have did in week 10? Week 10 revolves around the regression, which is nothing but the training of the data. So what we do in the regression, if we have a mechanistic model, we try to predict the parameter. We try to predict the parameter such as R in V equal to I equal to V by R. If we do not have a mechanistic model, then we go for empirical model. In empirical model, what we do by using the regression, we find out our empirical model by using this training data. This training data can use, suppose xi, yi, different I goes from 1 to n. By using these data, we can find out a model, then use this model to predict a value at some different point. That is the main goal. We want to find out y star at some unknown point, at some point x star. So there we have seen first the simple regression model. Simple means what? Only one regressor will be used, one regressor and one response. Linear means what? We have assumed that the response is linear with respect to regressor. There we have used the least square method to find out the regression coefficient. This W is known as bias and this W1 is known as weight. By minimizing the cost function, we have found out the W0 and W1. The W0 comes as W1 comes at x y bar minus x bar y bar divided by x square bar minus x bar whole square. And W0 was y0 y bar minus W0 W1 x bar. Okay. Then after that, we have seen the quality of regression. There we have defined what? We have defined two things. First things is what? The coefficient of determination that was written as R square, that was equal to SS of R and SS of T in sum of square of regression divided by sum of square of total. So that always lies between 0 to 1. If it is close to 1, if it is close to 1 means what? The model is capturing the value. Model is able to capture the value. And if it is close to 0 means what? The model is not able to capture the variation in Y. Then the under root of coefficient of determination is called as correlation coefficient. So this correlation, when R is greater than 0, means positive correlation, means what? If X is increased, the Y will also increase. If R is less than 0, implies it is a negative correlation, means what? As we will increase the X, Y will decrease. If R is equal to 0, means what? There is no correlation between X and Y, means what? X and Y are not linearly dependent, which we have assumed before solving the problem. Then we have seen the multiple linear regression. There we have seen as long as our normal equations are linear, the linear regression can be applied. Okay. After that, we have seen the vector notation of the simple linear regression that can be applied for multiple linear regression directly. And it is kind of easier to implement in the computer. Then we have seen what? We have seen we can convert the non-linear regression into the linear regression problem. But there is one condition, that once we converted the problem into a linear regression problem, in that equation, the noise should be in additive form. Once we have converted into a linear form, the noise should be in additive form. Okay. Yet, so this is problem solving session of week 10. So thank you. We'll meet in week 11, where we will discuss the problems based on optimization. So I am stopping the recording here. Thank you.